Okay, welcome back. Today we're going to learn matrix inverses, okay? We're going to see their application and what we can do with them. To me, this is pretty cool stuff. I can't wait to show you this. It's just showing you just the usefulness of what a matrix can do. It really is. And I know you probably do not care. You just want to say, Mr. McCullough, just teach me what I need to do so I can pass the test. Okay, here we go. All right, our first little definition slide here. Okay, the identity matrix for multiplication. Okay, so if you remember, and you better not have forgot. I'll be so upset if you forgot about this. Our first lesson in school, we talked about inverses a little bit, and let's look specifically at inverse multiplication. Okay, when it comes to multiplication, the inverse of any element was its reciprocal, right? So the inverse for 7 was 1 over 7. When I multiplied those two, I got 1. And 1 was the identity element, right? So for instance, any identity element is pretty much you get the number back. You don't change its identity. See, there's a reason for that word. 7 times 1 gives me 7, okay? So the goal is take this information and apply it to a matrix scenario. So what can I multiply a matrix by and get the same matrix again? What is 1 for a matrix, right? Okay. And if I multiply two matrices together and I get the identity, then they must be inverses. That's the big concept for today. So how do I multiply by 1? Hey, it's this guy, okay? This is your identity matrix. 1's in the diagonal, 0's in the other diagonal, okay? This is the guy that when you multiply either by the right or the left of this matrix, you'll get the matrix back again, okay? You get, it's pretty, like I said, you're multiplying it by 1, okay? We call these square matrices. A square matrix is when the rows and columns are the same. Okay, it looks like a square, doesn't it, when they are the same? Okay, so that's just what a square matrix is. We're only going to worry about 2 by 2s for this lesson. Could you do 3 by 3s, 4 by 4s? Yeah, no problem. But for a high school class, I think 2 by 2 is just perfect for it. Okay, let's do an example. Determine if these guys are inverses, okay? So if they are and truly are inverses, then I should get the identity element, okay? This is 1. So let's see if it works. So we have 3, negative 1, negative 2, 1, times this guy. We haven't done multiplication in a long time. It's been a long time. I like to repeat myself for some reason today. No clue why. It's always row by column. And remember, the dimensions, the inner dimensions have to match. Now, since we're only dealing with square matrices, I don't have to worry too much about this, but it's a good reminder. So here we go. We're going to take this row, multiply it by this column. So let's see, that's a 3, right? That's a negative 2. If I add them up, I get 1. Then we do the next column. 3 times 2 is 6, plus a negative 6, right? When I multiply these guys, it gives me a 0. We're going to change the row. This guy, go through the same method, row by column. So this gives me a negative 1 plus a 1 is a 0. Negative 2 plus 3 gives me a 1. Now, since we already did a lesson on matrix multiplication, I'm not writing out that simplifying step. I'm going right to the answer, okay? Now, according to the definition, if I change the order, I will still get my identity matrix. Still get 1. Let's see if it works. Well, let's just verify. Let's take this row. So that's 3, right? Plus a negative 2 gives me 1. Negative 2 plus 2 gives me 0. Now we're going to erase this, go to the next row. We have 3 and negative 3 gives me 0. Negative 2 and 3 gives me 1. Yep. So we could say, yes, they are inverses. Okay? And if you ever get confused, go back to our first lesson, which I know you remember, and use the simple cases. Okay, what's an inverse again? What does identity look like? And just by looking at this might make a lot more sense. Okay, so just don't forget that in the back of your mind. All right, next up. Determine if these two matrices are inverses. Okay? All right, let's try it again. So we have here 3, 4, 2, 4. Okay, let's see if we get the identity. So we're going to do this row by this column. So 3 and what? Negative 2 gives me a 1. This is negative 9, negative 4, negative 13. Okay, this row's done. Let's go to the next one. 4, negative 4 is 0. Negative 12, negative 8, negative 20. Nope. They are not inverses of each other. Do I check the other? Do I flip these and see if it works? You can, but an inverse, it doesn't matter which way you multiply, you still get the identity. So I can stop here. There's no reason for me to move on. So this doesn't work. Okay? I have a couple more examples in the notes if you want to take a look at them, but that's as far as we're going to go for this video. Okay? All right. Now, how do we find the inverse of a matrix? We know how to test it. The test is just multiply. But how do I figure it out? Okay, so here's the formula for it. Now notice, I'm going to rewrite this formula, by the way. Okay? So to figure this out, this matrix right here, to find its inverse, you do AD minus BC. So that's 1 over that result when you subtract them. And in this matrix, we flip the diagonal. The other diagonal, we change the signs. Okay? Now, if you look at this first part, isn't that the determinant of A, matrix A, right? This guy is the determinant. So I'm going to rewrite that. It's 1 over the determinant times, okay, switch the diagonal here and take the opposite of the other diagonal signs, okay? If I do this calculation, I can figure out what the inverse of this matrix is, okay? Let's try an example out. Now, I want to be very clear. If this is 0, 1 over 0 is undefined, right? So let's think about it. If that's the case, can this have an inverse? No, it cannot. Okay? So just be very clear on that. If the determinant of a matrix is 0, there is no inverse. Okay? All right. So let's start off with this example. So we want to find the inverse of this guy. Okay? And before I do that, I'm going to rewrite the matrix here. Just like so. Okay. Now, if I look at the formula, I need to know what the determinant is. So I'm going to do that first. So the determinant of S. Let's see, this diagonal gives me a 2 minus this guy, which is 0. Okay, so my determinant is going to be a 2. Now what I'm going to do is plug it into this formula. So 1 over 2 times, now I try to shortcut the way I say this. I'm going to take these two and flip them. The other diagonal, I'll change the signs. Now 0, there's no sign change for it, but 8 becomes a negative 8. Now, this is called a scalar. You do remember that, right? I hope you remember that. You better. I'll come down, I'll come to your house. I'll make sure you remember this. Take half of this whole guy. That sounded creepy. You know what? Oh, I can't edit a video right now. Oh well, it's stuck. It's there forever. So we take half of this entire matrix here. So we get what? -1, -4, 0, and -1/2. So here is the inverse for S, just like that. We could check. Check. Let's multiply these guys and see if we get it to work. Now, I'm not going to switch them and multiply again to see. I'm just going to, this will be good enough for right now, okay? So, we have this first row. So that's a 1 and a 0 gives me 1. Then 0 and 0 added together gives me a 0. Okay, now we're going to do this row. So that's what? -8, +8 gives me 0, 0, and a 1. When I add them, it gives me a 1. So yeah, this works. They are inverses. Okay? Not bad, huh? The big part is just knowing this formula here. Okay? That's all you need to remember. Now, I want to be clear. You could find the inverse a different way. I'm not going to really discuss too much into it, just because I think there's a lot going on so far. We've done a whole unit, a whole chapter of matrices, and I think you have a good foundation. So I'm not going to show you every method. I'll leave that for your college professors, okay? But if you want to, I can always do a video on it in the future. Just let me know. So as you can see on this slide, I can check my answers, and I do get the identity, so they are inverses of each other. Okay? All right, let's try another example out. So different matrix. Ooh, this is gone. So let's see, T is this matrix right here. And we want to find its matrix, or its inverse matrix. And first find the determinant, right? So the determinant of T, so if I multiply these guys together, I get -12 minus another -12, just like that. When I'm done with this, I get, I get 0. Stop the presses. We're done. If I write this out, I get 1/0 times, we switch the column, or switch the first diagonal, change the signs of the other one. Okay, that's what it would look like, but this is undefined, right? So this matrix has no inverse. Okay? There's no inverse for that. I cannot multiply this by a matrix to get me the identity. It will not happen. Okay? So we could stop there, which is pretty good. It's pretty nice. I don't have to continue with the calculation. Okay? All right. So that is, what, 2 examples of just saying, hey, is this an inverse? And this is 2 examples of how do you find an inverse? Let's do a word problem. Why not? Let's do a word problem, right? So here's the deal. Let's say I want to solve that board's taken. There we go. You know, with 4 whiteboards, you think I have enough space. I never do. All right, so what is the purpose of an inverse? Well, let's take a look here. Let's say I want to solve for x here, right? Okay. And notice, you want to keep in mind that A, B, and x, each one of them is a matrix. Okay. Well, if I want to solve for this, I have to undo A, right? Bring it over here to get x by itself. When I do that, I'm going to do it in terms of a matrix. Okay, it's a little bit different. So if I multiply both sides by the inverse, just like this, okay, a couple things happen. One, when I multiply these 2 guys together, I get the identity, which is I. Remember, I is like multiplying by 1. And on the other side, I get the inverse times whatever B is. Okay? If I continue, I times x just gives me x. And then over here, I would multiply these two guys together, and I'll get my final answer as to what the variable is, what my unknown is. Okay? Typically, think of it, when we did this in just normal algebra sets, you divide both sides by a, you're done, because that undid multiplication. When we talk about a matrix, we have a different method of doing it. We've got to use the inverse. When I multiply by the inverse, I get the identity, which is like 1, right? Okay? 1 times x gives me x. And the other side, I got to repeat the pattern. Now, just to be clear, you see how I multiply both sides to the left, okay? I want to make sure that I maintain that. We talked about in the past how commutative property is not always true when you multiply matrices, okay? When I'm doing this, I want to make sure that I'm multiplying it in this order. Now, why does that matter? For this, it doesn't matter too much because I can still rearrange some things. I'm still going to get I. Still probably not the best thing to say that, but we'll keep it at that. Now over here, if I multiplied it the other side, okay, first off, this is not the same as this, right? We talked about how multiplication doesn't work that way. Plus, this might be undefined, right? It might not match up, the dimensions. So that's why when you're multiplying both sides by the inverse, you have to be careful. If it's to the left, make sure you multiply both by the left of it. And you will for these examples. So here's a nice algebra way of seeing what we're going to do in this example. Okay. Oh. I was trying to push it. I was trying to push it up to the left, but there's already a board here. Oh, wow. Fun, fun, fun. Okay. So let's take a look at this example as I'm erasing the board. And in fact, I'm going to leave that up there. We're going to need it. Rental costs. The Booster Club for North High School plans a picnic. The rental company charges $15 to rent a popcorn machine, $18 to rent a water cooler. The club spends $261 for a total of 15 items. How many of each do they rent? Now, I would not think of matrices right off the bat. Okay, go back to the beginning of the year where we start talking about a system. X, well, that could represent what? Popcorn machine. Y could be the water cooler. So if I add the number of items here, I should get 15. That's my first equation. My second equation is the price, right? 15 times how many popcorn machines I have, 18 times how many water coolers I have, right? So that should add to $261 total is what they spend. So how many of each item did they really come up with? So I'm going to take this and create a matrix equation for it, okay? So let's break down what this looks like. Because at first you're probably thinking, this is weird. Guess what? It's weird, okay? So here we go. And what I wrote on that whiteboard over there is going to come into play as well. So this is my A matrix. And you remember, this is my coefficient matrix, right? I took this equation, I plucked out the numbers, and I put it here, all those coefficients. Now, I'm going to times it by this guy. This is my X matrix, okay, or my constant. Oh, not constant, I'm sorry. My variable matrix, okay, and this guy B, I'll call this matrix B, is my constant matrix. So this is my coefficient matrix, okay? Now you're probably thinking, why is this here? Why do I even have that? Couldn't I just solve this how I did in the previous lesson when we're solving a system? Yeah, you could, all right? But if you're not convinced as to, does this translate to that? Multiply. If I multiply this row by this column, I get 1x and 1y equals 15. Let's multiply this row by this guy. I get 15x plus 18y equals 261. So technically, if I multiply these two guys together, I do get the original. Okay? Pretty cool, huh? Now, let's take a look at this guy over here. Boom. So this is what I have, right? Okay. So to solve this, I'm going to multiply both sides by the inverse. This simplifies to just the constant, or not the constant, the variable matrix. And then over here, if I multiply the inverse by the constant b, I get my answer for this guy. Okay? So that's what I'm going to do. So my first step, find the inverse. Find the inverse. Find the inverse. Doesn't work unless you sing, find the inverse. Okay, so if I'm going to find the inverse, I need to find the determinant first, right? That's up here. So let's find the determinant of A. So that's going to be what? 1 times 18 is 18. 1 times 15, 15. So the determinant is 3. Okay? All right. So we do 1 over 3 times, okay, now we're going to change the matrix a little bit. So we're going to flip the diagonal. The other diagonal, we change the signs. Just like that. Okay? So now, to finish it, I'm almost out of space. Oh no! A third times 18 is 6. A third times -1 is -1 third. A third times -15 is -5. A third times 1 is a third. Okay, so this guy is my inverse. Okay? Now we've already done that before. Now what do? Well, you get a new whiteboard. That's what you do. We need another whiteboard. I'm out of space. Okay, so I'm going to multiply both sides by the inverse, right? So here we go. This, and I will say this is a lot to write, so give me a moment. Okay, times. And then there. Woo! In fact, let's write the symbols underneath. So this is the inverse, right? Times A times X equals the inverse times B. Be careful. You see how I multiply the inverse to the left of this? I can do the same thing over here, multiply to the left of that guy. Okay? You can't switch the order or else it's not going to work. That just comes down to matrix multiplication, right? Alrighty. If I multiply these two guys together, I get an I. Okay, I get the identity. In fact, let me write that out. Don't be sloppy, John. Write that out. Okay. There we go. So if I were to rewrite the symbols, this is the identity times the matrix, or the variable matrix. And then here's the inverse times the constant, which I did not simplify yet. Please, I beg you, make sure that that comes out to I, okay? For the length of my whiteboard and the length of this video, I'm telling you that when I multiply these two, I do get the identity, okay? All right, now if I multiply these two guys together, because this is like multiplying by 1, I just get that guy back. Now over here, I'm going to truly multiply this guy. Now, do the dimensions work? They do. Here's a 2 by 2, 2 by 1. Inner dimensions match. Okay, so I'm allowed to multiply this. If you have this on the other side, you won't be able to, right? So just keep that in mind. Okay, now, so we're going to multiply the top row by this, and my numbers. Yeah, I'm going to cheat. Usually I'll have a calculator here on standby, but I'm going to cheat a little bit. Okay. All right. So 6 times 15 plus -1 third times 261. Woo! That is a lot there, okay? Did that work out? Yeah. Add those up together, we get a 9. Sorry about that. I was looking at my notes as how I simplified. For a moment there, I thought I had it shifted up, okay? Actually, I'm sorry, it's not 9, it's 3. See, told you. Looking back and forth on this thing, okay? And then this row multiplied by this column, so -5 times -15 plus a third times 261, we get 12 for that guy. So if we take a look, x is 3, y is 12. Or we should write it as a point, right? Okay. Remember, this is a system, so we should write it as a point where the two lines intersect at. Okay. And we're done. That's it. So, I mean, I did skip the simplifying step for that, just for space reasons. And I did multiply this out to show you it's the identity, but I'm assuming you're okay with that you could do that. Okay. All right. So there's a word problem that you could try out in my notes. So if you want additional practice, it's there for you. I want to finish this lesson talking about solutions for a second. I think that'll be important. Okay. Let's go back to this guy right here. All right. Notice, because this had an inverse, the determinant wasn't 0, right? Let's say the determinant was 0. If this came out to be 0, what does that mean? Well, there's no answer to this guy. Uh-oh. What's that mean? Well, think of it this way. I'm going to erase this. Because this is the important part of why determinants are useful. Okay? So let's say, for instance, I had this. Okay? And if I find its determinant, I get 4 minus 4, which is 0, right? Let me write the equation out. 1x plus 2y, 2x plus 4y. That's what it looks like as a system. So notice something here. Aren't these the same? If I multiply this by 2, don't I get this bottom equation? Do you remember that from a long time ago? Okay. So if that's the case, if they're the same line, then a determinant of 0 is telling me I could have infinite solutions, right? So there's no inverse, but that just means I have infinite solutions there. That's pretty cool. What you think? What else could happen? Well, remember you could have parallel lines, right? If I go back to this guy here, let me do the same equation. And let me just write this out. So this is saying x plus 2y equals 5, 2x plus 4y equals 7. If I was going to solve this, I'd multiply this by 2, right? So multiply this by 2, and then add the equations together to eliminate some variables, right? If I was going to solve this system, it actually would be a -2. So this is 0, this is 0. Okay, on this side I get what? -10, and that gives me -3. And we said, hey, this is no solution. Okay, and the reason why it's no solution is because they're parallel lines. All right? So another thing you could think about is if the determinant is 0, we have two cases. It could be infinite solutions, it's the same line, and that could happen if this is what? 7 as well, if it's identical. Or actually, I'm sorry, if this is 3.5, right? And I multiply by the -2. Okay, or I get a situation where there's no solutions, the determinant's still 0, and that means I have parallel lines here. Okay? Does that make sense? So a determinant tells me what I'm looking at here, visually, geometrically. Okay? One final thing I want to add to this, and then we'll end the video. If an inverse exists, that means that this system has an answer. And that answer is unique, okay? So if there's an inverse, and it exists, that's a unique solution, okay? Meaning that's the only answer that works for this guy. Unlike in this example here, there was no uniqueness, right? Either there's a lot of answers for this system or there was no answers. But if the inverse exists, we could say that there is a unique solution for that guy, okay? So it does work out. That's it, guys, okay? Sorry about the ending there. I wanted to verify why a determinant equals 0 is important. Not only does it tell us that there's no inverse, but it also tells us that we can have like a no solution or infinite solution. And that's just as important. All right? My notes are uploaded for you guys, so you can look at some of the other examples. I hope you're doing well, and I will see all of you in the next lesson. Take care, guys.